Alright. Oh, everything is borked on OBS. Give me 1 second. Okay, everything is fixed. We're gonna get started right about now? Alright. Can everybody here see me alright? Speeding at sea, it's me, Z. Hello everybody, I hope everybody is having a spectacular day. Alright, I have been running very back-to-back today, so I hope I didn't forget anything before things are setting up. Okay, everything sounds good, looks good. Alright, that is great to hear. Yeah, I don't know what's going on with the weird function where you can be ranked now. Orbeez, I think I'm gonna have to rank you all. I'm gonna have to assign every Orbeez into a specific tier. The background looks exactly like my Physics 1 class. No. We are here. Well, the Physics 1 class may be associated with positive things. In that case, we are bringing back positive memories. If your physics class is not associated with positive memories, then in that case, we are going to reassign positive memories to this location. Alright, I'm gonna do a quick attendance. So if you're here, please say here. Hello Warpy, hello Apa, hello The Large Hadron, hello MDB, hello Eggy, hello Astral, hello Brenda, hello Pembu, hello Headhunter Zilla, hello Large Hadron, I think I may have already said that, hello Space Guy, hello Stella Curie, hello Philippe, hello Josem, hello Umyu, hello Benjamin, hello Nikki, hello Guiyi, hello Swirly Bro, hello Sparky Bro, and hello Professor Fun. Wow, yeah, no, it looks like there are quite a few new viewers here. Well, if you're new to my channel, thank you so much for stopping by. And I'd say if there is one stream that you should be joining for the first time, it is definitely this one, because I have been so excited to talk about this. You guys have no idea. You guys have no idea. Well, now that roll call is complete, thank you. Thank you for marking yourselves as present. I hope everybody has been having a spectacular day, a spectacular weekend. Yes, welcome to the new viewers as well. It's big brain time. Will there be a test? I'm not good at astro stuff. Well, there won't be a test, but you'll be graded based off of your excitement, which should be very easy considering that these photos are very exciting. Is attendance mandatory? Yes, attendance is mandatory. If you do not attend, you will be exterminated. I'm just joking. Oh, well, I was kind of procrastinating on these slides because there were a lot of last-minute things that I wanted to include, but I think it'll be pretty good and pretty casual. So the way that this is going to work is, I know in the past my live lectures have been a bit more formal. For this, I definitely wanted to be open to questions, so if you have any questions, feel free to ask. That being said, I'm not like 100% an expert on this, so there might be some things that I'll have to Google and look up, and some things that if you in the chat are more knowledgeable than I am, definitely please go ahead and answer questions as well. I like how 7 people have like 75 XP, but the order seems random. Yeah, I don't know what this ranking thing is. I clicked top fans and it seems like everybody is ranked. I think it's based off of the number of times you chat. And if you do like a super chat or something, you can also gain points. This is a really interesting feature, but yeah. All right, well, it looks like Joseph is asking some questions. What is this? What are we looking at? So Orbeez, what do you guys feel about getting started? Getting started? All right. Well, this is the Rubin Observatory, and it's basically the topic of everything I'm going to be talking about today. It is the result of more than 2 decades of work. And it is an incredible observatory that's hosting the largest camera that has ever been built in world history. Its goal is to take thousands of images of the sky every night, and I'll show you some photos as well. I'm just giving a brief overview. And by surveying the sky every night, it will basically be a game changer in identifying so many comets, asteroids, galaxies, supernova events, interstellar objects, and more. And I'll actually be showcasing some of the data previews and exciting first photos that have been released already. What is a robin? Well, it's not Robin, it's Rubin, and it's actually named after a famous astronomer, Vera Rubin. And I actually have a slide about her, but it's going to be a bit later because I think what's really important about Vera Rubin is also what she discovered. Space Guy Rai asks, did you hear about the new interstellar object they detected a few days ago? Yes, I've actually had a bunch of like friends and stuff like send me articles about this, but frankly, I haven't had the time to really look over it yet. But I think like, it sounds pretty exciting. I remember when Oumuamua was like visiting the solar system, and there was a lot of excitement about that too. When we have time, like we should definitely like just Google it together because I definitely want to read more. So, I'd say that a lot of the images that I have on here are from the Rubin Observatory website. They have a lot of great public images, but if you really want to delve into the first look images, which was the first images released to the public, then there was an amazing live stream that was done a few weeks ago. It was so funny because I was actually in an Uber, like just getting off of a flight, and I was wanting to, you know, like sit down and watch this, but I was in an Uber, like so excited to see this, and it was extraordinary, even from the tiny screen of my phone, looking at these first look photos. So if you want to check out this live stream, it is really, really great. So, okay, where is the observatory? The observatory is in Chile, which is great because it's high up in elevation, and so you can see closer to the night sky, and there's very little light pollution. All right, so you might be wondering, so Z, actually you might not be wondering this, but I am wondering this. Z, why is this so exciting, and what has your exposure been to this telescope? And the answer to that is that simply I have actually seen the camera itself before it was sent out to Chile. First off, let me upload the link to the first look live stream, which does a really good job of explaining stuff. That's exactly what I was wondering. Thank you. Here, I'm gonna pin links like throughout this so you guys can access them. The building process took a really long time, but also the ideation. The first ideation of this came in like 1996. So it took a really long time for them to actually put it into creation. But the big thing was definitely the technology being built. Chilean here, we are proud of our observatories. Yeah, no, Chile's great. Chile's amazing. It's so spectacular. So, Z saw the camera before it was shipped? What? Yes, I did see the camera before it was shipped. Here's a photo of it, actually. I don't know if it was fully complete in this photo. Oh, ideation means like, when they first thought about, the observatory. When they were first brainstorming the observatory. And thinking about, you know, what observatory would be best beneficial for astrophysics. They were thinking like a large-scale survey like the Rubin Observatory. So yes, so I did see the camera before it was shipped, and I don't think this photo even does it justice. For the American folk, the height of this camera is 5 feet and 5 inches. It's an absolute behemoth. And this is an actual photo that I took before it was shipped, which was really exciting. I don't know much about how the camera itself is like assembled, but this is the different parts, and it is absolutely humongous. Yeah, no, it's so awesome. I mean, it was unbelievable, like seeing it just there too in real life before it was sent out. Yeah, no, it's a big camera. Imagine being shorter than a camera. I mean, this is the world's largest camera. So even if you're shorter than the camera, I mean, this is a hard scale to beat. So you might be wondering, what exactly does this camera photograph? So the field of view of this camera is 45 times the area of the full moon. It will take a photo of the entire southern sky every 3 to 4 nights, meaning that it's literally the greatest astronomical movie of all time. And this is sort of an example of the different like CCDs that are comprising the camera. And I think the first look live stream also explains this too. If you wanted to see a single photo from this camera in its full crisp quality, you would need 4,000 4K TVs. I think that's like a basketball court's, I think they said it was a basketball court's worth of TVs, which is insane. You know what I really would have loved to see? I know this is absolutely unfeasible, but if, for the first look live stream, if they actually got 4,000 4K TVs to like display one image, that would have been so cool. I mean, that being said, that's like absolutely insane, but like, I don't know, it would be cool to see it. Oh my god! Thank you, Tyler, for the super chat. Actually, this is my very first super chat ever. Thank you so much. I'm gonna like that. Thank you so much. I really appreciate it. I don't even know what to say because I've never been in this situation before. Thank you. The lens equation is giving me flashbacks. The thought of aligning is, yeah, no. The precision of this must have been insane. Yeah. What happens if we built something like the Rubin Observatory in space? I mean, it would not have been possible, frankly, because building something of this high precision, this camera is also really heavy. Sending this into space would have been really challenging and basically impossible. In addition, the advantage of having a telescope, the advantage of having a telescope on Earth is that if you need to tweak something, it's actually really easy to go fix it, because you can literally just go there. Now, the downside of that, of course, is like there could be like weather issues, and a big issue so far has also been satellite trails. But in exchange for that, you know, a camera of this size is impossible to put into space at our current technological standing. But maybe one day. Yeah, no, one day though. One day. Tyler says, I'm honored to be the first. Well, that actually bumped you up all the way to the top of the leaderboard. So congratulations. Oh yeah, here's a cool thing. So when they were building the camera, they wanted to get test images. And one thing that they took a test image of, or I guess attempted to, was this broccoli, where you could really see those fractal patterns. And this was also right next to the camera before it was shipped out. And there was also a test image of Vera Rubin, which is what the telescope's, who the telescope is named after. Why broccoli? The reason for that is because there are some really interesting fractal patterns, and so they were trying to look at stuff in really close detail, and I guess looking at the fractal patterns of broccoli is really intriguing. Just asking, can it be visited? That's a great question. I mean, as of now, probably not. I'm sure like once it starts its like 10-year survey, there could probably be some tours and that kind of stuff. That's actually a great question. Can I visit the Rubin Observatory? Oh, yeah. I mean, okay, yeah. To be fair, it's also in a remote mountaintop, so getting there is really hard. Yeah, it's still under construction. Though, I'd say, like, in the future... Oh, wait, they have this website called Visiting the Summit. Oh, the access to the site is restricted. But if you want, you can, it looks like you can fill out a form and they might get you access. But I think, like, for now, it's not open to the general public. Yeah, no, it's a really cool way to honor her. Yeah, I mean, this telescope, even naming it after her is really great. We can just break in. No, please do not break into the Vera Rubin Observatory. No, it's too precious. So yeah, so this is a really cool test image that I saw. That's actually it for the photos that I took. This was actually like quite a while back, so I didn't actually take that many photos. This was before I became a VTuber, obviously. So, but it was really cool to see it and really extraordinary. So you might be wondering, how many filters does this camera have? It looks from the ultraviolet to the near infrared, and it has a total of 6 filters. But the first look images were just with 4 out of the 6 filters. So considering that it's UV to near IR, it's not the lights that our eyes would see. And what's really exciting is that you can actually switch out the filters for these images. Now, that in itself is a very, very challenging process, and I actually learned this recently, but the way that they designed it is that you can only have 5 filters in the telescope at one given time. So if you want to switch to the 6th one, like, it's an insane process. Yeah, probably need to get published in Nature or something to get access. Maybe you just have to be an astrophysics researcher, go through grad school, get a PhD. just to see what the Rubin Observatory looks like. I'm sure they'll probably also have like job openings and stuff, even like non-science jobs, because of course running an observatory is very challenging, and especially something of this scale. What are satellite trails? Asked Josem. So when you think of like Starlink satellites in the night sky, or satellites in the night sky in general, sometimes they reflect the light from the sun, which means that when you see them in photos, it leads to these streaks of light going across the photo. I might actually have... Actually, I don't know if I can pull this up. I think I had a photo of these satellite trails. So when you take a long exposure photo, you are gathering a lot of light over a longer period of time. And satellites, especially bright satellites, also move across the sky. So you would imagine that the satellite would leave this bright trail in the image. And those are satellite trails. And they're a real nuisance to astronomers and astrophysicists, because when we want to observe things from the ground and there's this annoying satellite trail in the photo, it's really challenging to deal with. There are ways to avoid it. Some satellite companies have done their best to reduce the reflectivity of satellites, and now with like machine learning, it's much easier to remove satellite trails. But it's still a nuisance nonetheless, especially when you're in a really remote location and hoping to get the best image possible every night. Greetings to all friends in the stars. Hello, Trentimus. Or I guess, I don't know if you go by Trent or something for short. Oh yeah, I wanted to showcase this photo. Here, let me try to make this a little bit bigger. And maybe make chat a little smaller. This is a photo of the shipping container that held the giant LSST camera. The camera is called LSST. Basically on its way to the observatory. If I recall correctly, the way that they shipped this camera out was that they mounted it to a custom shipping frame and then wrapped it in this plastic electrostatic discharge material so that it could protect it from the moisture. And then they used like an overhead crane to like put it into a shipping container with like insane insulation to make sure that the camera would also not overheat. And then they like clamped the frame to like metal struts. And then there was also like GPS tracking, temperature, humidity, vibration, acceleration tracking, like all of these different trackers in this container as it was being shipped to this observatory. I don't know why they would need a GPS tracker, because I'd imagine it would be very challenging to lose or get stolen a giant 5'5" camera, but I guess maybe they were scared of, you know, maybe they wanted to pinpoint it, you know, throughout the journey. They also, turns out they had a full dress rehearsal for just the delivery of the camera in 2021. And then they had this like camera mass simulator, and they basically delivered it all the way to Chile to practice for the real deal, which is insane. Building looks like it's from 2001 A Space Odyssey. Yeah, no, it's a sick building. I mean, like, oh, it'd be so cool to see that. Yeah, it's also home to similar observatories. Yeah, exactly. Telescope heist. No, please, please don't steal the camera. I actually recently rewatched you can see me. Or was it called can you? Oh no, sorry, it's called Now You See Me. And that just reminded me of that. Please don't steal the camera. It would be embarrassing if we got damaged by the hot pothole. What's insane to me is that they did a full dress rehearsal for this. But I mean, it also comes to show the amount of dedication that they had to really putting this together. Yeah. I mean, this is insane. Here, I'm gonna move Zide back here. Now You See Me slabs. Wait, slabs in a good way? Actually, Orbeez, I'm curious. We're gonna take a brief Rubin break. Opinions on Now You See Me, because Now You See Me, I actually really liked Now You See Me 2 more than Now You See Me 1. And I think there's a third one coming out that's titled like Now You See Me 3, Now You Don't. I don't know why they didn't name the second one Now You Don't, but it's, yeah. Now You See Me, Now You See Me. Orbeez, I'm actually making my movie debut in the third movie of the Now You See Me trilogy. You've never seen it? I think it's a movie worth watching. I think it actually recently got added to Netflix. It's great. It's a great movie. Isn't it also important to have reflective stuff on the satellites so it doesn't overheat and absorb too much radiation? I don't know too much about satellites to know why, but I think, like, there's a way to reach a middle ground. Of course, you can't paint the satellite black, because that would be a little intense. But if I recall correctly, some of the early Starlink satellites that were being launched, they just weren't thinking about the implications for astrophysics and, like, observational astronomy. So, of course, now that they're more conscious of it, they started putting, like, less reflective stuff. I don't know too much about this. If somebody in the chat knows more, please feel free to hop in. I love the card trick scene. Yeah, no, honestly, the whole movie is so fun. Ocean's 11 is also great. I liked, more than I liked Ocean's 11? Was it Ocean's 9? No, Ocean's 8. I actually liked Ocean's 8 more than Ocean's 11, which might be very controversial. Satellites have electro-vacuum isolation similar to the foil on the Apollo lander. Oh! Oh my god! Thank you, Tyler3978, for joining the main sequence! Oh my god, I low-key got jump scared by that! I was like, who's playing Among Us? Thank you so much. Actually, speaking of, I need to welcome, there are 2 new members who also joined, between, the streams. Thank you to Guiyi for becoming a red supergiant. And thank you to Volsoon for joining the main sequence. And if you're a member, be sure to also join the Discord, because you'll get access to the members only Discord, where I have been posting some really exciting things. Like just today, actually, I just posted a little violin clip, because I'm just getting back into violin. Sorry for scaring you, don't worry. When is Rubin Telescope getting anime girled? I mean, you could easily just put anime eyes on it. Among Us stream when? In the near future. I think that could be a good membership stream, actually. The astrologer emotes. See, I'm still getting the hang of this, but I think I need a certain number of members to unlock some more emoji slots. So I think I can add maybe one more. So next stream, you'll probably see it. Oh, the violin was fantastic. Yes, thank you so much. And for those of you who aren't members, don't worry. I'll probably be I am working on some covers soon. Yeah, hello Loak. Thank you so much for joining. Oh my god. Hello, thank you Professor Fun for also joining the Red Super Giant tier. Thank you so much. Oh my god, I really appreciate it. I guess the violin clip seems to be a very lucrative business offer. I play that violin clip every so often because it's so soothing. Thank you so much. I think I'm more critical of myself, and I listen to the clip and I'm like, oh my god, my intonation was off here, like my vibrato was too shaky here, but I'm really glad you guys enjoy it, and honestly makes my heart feel more full, because I haven't practiced in such a long time. Thank Tyler for this, he pushed me to the edge. Thank you, Tyler. Tyler is the great leader. Okay, well, okay, that was a nice fun break. We talked about Now You See Me, we talked about violining. I have a lot of things to cover, so the next up is this really exciting article. I think you guys, if you don't have a New York Times account, it might be a little hard to access this, but this was the New York Times photo of the Rubin Observatory, and it looks absolutely spectacular. And one of the quotes that I really liked from this article said that 10 of the images from the Rubin camera will contain roughly as much data as all of the words that the New York Times has published in print during its 173-year history. And what's even crazier is that Rubin will capture about 1,000 images each night. Isn't that insane? The total amount of data that the Rubin Observatory will get is 60 million billion bytes of data. So that's a 6 with 16 zeros. I mean, that's absolutely insane. Yeah, no, it's crazy. Yeah, no, I literally am that, like, loading emote. Oh, no ads here. Yeah. So if the observatory is so hard to reach, where do the researchers stay while they're there? I'm sure that there's probably housing nearby, or... I actually don't know anyone who actively works at the Rubin Observatory. Like, physically there. Oh, there has a summit facility. Interesting. Oh, that, like, building that kind of seems to, like, you see this building down here? Interesting. Actually, let me actually show this real quick. I think you guys will like this. So the building has a elevator. So looks like there's a control room in here and a machine shop. And there's a camera clean room. I thought people would stay here, but it looks like not a lot of people stay there. I guess this is mostly for servicing. So the people who would stay here would help service the telescope and make sure that it stays all right. Yeah, it just looks like a giant room. I would presume that there are, like, nearby housing, because there's also a lot of observatories in the area. Oh, stargazing there would be absolutely insane. That's the dream. Actually, Orbeez, I want to do a survey, because I actually did a survey recently of some of my friends, and I was really surprised at the answer. The question is, have you seen the Milky Way with your eyes? I'm gonna unpin this. And what was really surprising to me is a lot of people say no, but what was even more surprising to me was that there are people that I know who are, like, pursuing PhDs in astrophysics, and they had never seen the Milky Way with their own eyes. And I think that really comes to show how bad light pollution is, and maybe it's also the weather, but I feel like it's urbanization, light pollution, that kind of stuff. Yeah. I returned, our electricity went out. Well, maybe you got to see the Milky Way for a second. Too much light pollution. Yeah, no. And there's actually not there are some areas that are protected, designated night sky sites, but it's becoming increasingly challenging to keep those areas safe. I've only seen it once, and maybe like 1.5 times, but I've gotten a few recommendations. National parks definitely seem to be the best bet. It affects a lot of bat populations too. Yeah, I heard it also affects a lot of bird populations, like migration. I've not seen the Milky Way with my naked eyeballs. 70%, 30%. Yeah, I'd say that was roughly the same when I polled some people. Yeah, it's really unfortunate. I've never seen an aurora borealis as well. Yeah, is Wales? I don't know about you, but I don't think Wales is that clear. No? I thought Wales doesn't have great weather. Back in elementary school for a trip. Yeah. I think it's like... I think some people see like fuzziness. That's what I saw when I saw the Milky Way for the first time. But, you know, you don't see it like sharp, right? But I know some people who visited certain national parks and they were like, yeah, it looks exactly as crisp as the images. I think that is a really rare occasion. I've seen auroras 3 times from my home. What? Can I just steal one of those auroras? Well, yeah. Anyways, without much further ado, while some of you guys are filling out the poll, I think it's 3070 though, so I might just end it. Let me see. I definitely want to go over the first look images with you guys. Oh, I hate this. For the poll, why does it say no is 69% and yes is 30%? What is this rounding error? Space Guy says, I went deep in the mountains in California. Milky Way is amazing. Never seen the aurora though. Was disappointed. Yeah, no, I thought I could see it when it was further south, but because I was traveling during that, there was like one day where it was really peak and I was traveling south, so I just couldn't see it at all. So, yeah. But I do know some people in the UK who were able to literally see the aurora with their eyes, which was crazy. I did get to see a solar eclipse though. That was spectacular. I can see why people chase that. YouTube has a bias for that 69. Seeing the core with the naked eye was the reason I got into astrophotography recently. Ooh! Actually, if you have some astrophotography, we do have an astrophotography channel in the Discord, so I'd love to see. I was in the path of totality last year. Actually, next poll should be, have you seen the aurora borealis with your naked eye? Oh, well, I guess aurora borealis is always sort of with your naked eye. Actually, no, I did see a little bit of aurora borealis once, and it was through like a camera with an infrared filter, but I'm not sure if that really counts. Yeah, I'd say it's a greater percentage for aurora borealis. I mean, even I haven't seen it. But I thought it was crazy that there are some people who are literally studying the Milky Way and plan to study the Milky Way for the rest of their life, and they have not seen it visibly. I think that's actually really tragic. Have you seen any meteors? Yes, I've seen a few meteors. I remember I actually chased a meteor shower once and I saw a really bright meteor. It was spectacular. No, I was just outside of the range of the aurora. 90%, 10%. I think with the solar storms recently, the yes percentage has gone up for sure. Alright, great. Oh my god, why is the rounding still happening? No is 90%, yes is 9%. Okay, well, we've been getting off task because I really want to talk about the first look images. So yes, let's look. Yay! Oh my god, so this was the first look image that was dropped by the Rubin Observatory. And Orbeez, the moment I saw this, I just stared at it. Keep in mind that I was in an Uber And I felt kind of bad because the Uber driver was trying to talk to me, and I actually tend to be like more talkative like in an Uber. But in this instance, I was like mouth shut, like I was just looking at this photo. I was absolutely blown away. And then immediately I was like texting other people, and then I downloaded it and I set it as my phone wallpaper. Yeah, I mean, we're gonna go a little bit more in detail, but like, just look at the immense, like, look at that activity going on here, the interaction here, the two gorgeous spirals here at the bottom. I mean, like, so this first image apparently has 10 million galaxies. Isn't that insane? New dress idea? Well, I'm sure I'll probably get some sort of like copyright strike if I use this for my channel, but actually I would love to get a new galaxy dress. I think that would be really pretty. Actually, this is the cosmic microwave background, but Mylan actually redrew it so I wouldn't get, you know, in trouble. It evokes the same feeling I got with the first James Webb photo. Oh my god, the first James Webb photos, I still remember that day. That was absolutely beautiful. I know, right? Like, how are they going to find anything in this? Well, don't worry, we're also going to cover that too. Oh. What? Oh, okay, yeah. I don't know if I have this set up. Let me see if I can get the audio to work. Here. I really wanted to show this video, so this was posted by the Rubin Observatory for their first look event, and I'm just gonna zoom in a little bit. Just have a look. I hope I don't get copyright striked, and if I do, I will just crop this part of the stream, but I don't even care if I get copyright striked, because I feel like this is such an amazing video. I mean, it's so beautiful. I'm actually gonna, can I... Oh, copy video URL. Okay. I'm just gonna paste that here. If you, I recommend that you watch this like with headphones on, noise canceling on, full screen. It's great. Let me go to the next slide. Oh, oops, sorry. I know, it's absolutely insane. And this is the second photo that they released, which has the Trifid Nebula up there and the Lagoon Nebula down there. And these are birthplaces of stars. And the Rubin Observatory took this by combining these like 30-second exposures and stacking them to produce a photo that has such incredible detail. So this photo is actually 678 separate images taken over 7 hours of observation time. So, I mean, like, I'm at a loss of words. It's just so pink. I mean, as long as you give credit. Yeah, and, great. Thank you, Pembu, for checking. Pembu is my amazing mod. Thank you so much for checking. I will, have all of these... I will actually link the slides after this is done, and I'll also link some of the videos down in the YouTube description as well. You can mirror the video. That works too. I mean, it's pink because it's blushing. I mean, the Lagoon Nebula is actually my favorite nebula. So when they dropped this photo, Orbeez, you have no idea how fast I scrambled to see this. I mean, it's just insane. Like, you could just see the gas and dust. The bright blue stars around here are like newborn baby stars. It's just an incredible photo. Why is it pink? Well, so the filters that the Rubin Observatory has aren't actual colors that we can see with our own eyes. But pink and redder regions tend to be associated with star-forming regions, like star-forming gas clouds. And so the reason why it's pink is because these are star-forming regions. And you can also see the little blue stars being like born in between them. It's great. Yeah, I'd say it's a false color image, but I think even that is like a little misleading. I think when you say false color image, people think like, oh, like this was supposed to be blue, but they colored it red. And yes, like we can't see infrared, but if our photo was like real colored, like we wouldn't be able to see much. It's more so assigning different colors to different filters so that we can see the image in its totality. Yeah, no, it's great. So the next thing I want to go over is this website called SkySynth. Oh, not SkySynth. That's the next one. Skyviewer.app. Actually, let me... I actually had a slide on this, so I'm going to move this up a little bit. Just give me 1 second. Great. Hopefully that... Yes, skyviewer.app. Boop. I want to explore. So let me actually also link this. Oh. I hope that actually didn't dox me. Okay, yes, we're fine. We're fine. Boop. We're gonna replace the pin message. So you guys can follow along on this. This is, oh my god, it's kind of laggy, but this is the website that they created, that the Rubin Observatory created, so that people can actually explore the first look image. So I'm gonna try to zoom in. Chat, I'm gonna make you guys a little smaller. I'm gonna also make me a little smaller, and scooch myself over. And then we're gonna move that. Yeah, there we go. And then Zybe, I'm also gonna move you down. Okay, great. So this is great. I mean, like, you can zoom out all the way, and you can just zoom in continuously. Like, oh my god, this is great. Like, look at that galaxy interaction there. Like, that is just spectacular. So, oh my god, I can talk about this for ages. Like, you guys have no idea, like, what my screen time is on this website. Oh, no. We also haven't really talked that much about the science about this yet, so you haven't really missed much. So these kinds of yellow dots are actually galaxy clusters. There are many galaxies bound together. And if you look carefully, you might see some, like, blue-looking objects, like this one. Like, this is just a random location. These blue regions are star-forming regions in the galaxy. So that means that this galaxy is forming stars. Oh my god, my computer's fan is going haywire. You might also notice these, like, red dots. Most of these, especially the more rounder looking ones, like these guys, these are actually stars, because they're round. Galaxies don't tend to be, like, fully spherical. And they look more red because of the smearing of the light in the atmosphere. Oh my god, I am moving at like 3 frames per second, but it's okay because this is great. And you will definitely see a ton of these like random dots. Most galaxies that we'll find will look like that. So when they say they found 10 million galaxies in this image, it's like these guys. Like, but these galaxies are so far away, which means they're also really far back in time, which means that they are the earliest galaxies in the universe. Hello, Squad XEO. Happy 4th of July. Thank you so much. Well, I don't know if that's something I say thank you for. Happy 4th of July? It's not like happy birthday. Oh, yeah, no, my computer is heating up. Like, I can hear the fan and it's, like, really hot, but... Oh my god, like, look at this one. Like, look at its structure. I mean, it's great. Okay, wait. So, before I get too distracted, before my computer achieves nuclear fusion. So, obviously, I've spent a lot of time on this, but in addition, there are some finds that, some people in my research have also found, and I also wanted to share these with you guys because that's really exciting. So the first one is the first really odd galaxy is this one. Like, it has this... Oh, let me bring back the music. It has this weird... This galaxy has this weird green thing sticking out of it. And there was some conversation about what this could be. But the current theory is that it could be a AGN outflow. And for those of you guys who don't know what an AGN is, it's an active galactic nucleus. So it basically means like the supernova, the supermassive black hole at the center of galaxies. And in some instances, they're very, very active in that the dust around them are also producing radiation. It's producing jets. It looks like that could be the case. I'm just really intrigued by how green it is. I posted this into the Discord as well. And, I think Eggy was the one that said that it looked like a galaxy spitting out its vegetables. And I've just been referring it to that from now on. The second interesting find. Oh my god, my laptop is heating up. Like, just look at this galaxy interaction. Like, you can see that this, in the midst of this galaxy collision, this giant tail has been ejected out into space. It's just so spectacular. What does the green color mean? I have no idea. I have no idea why it looks green. Yeah, no, that Zilla is giving the proper reaction to this. I mean, like, this is insane. And, like, keep in mind that this is just, like, this is a random zoomed in location on this giant image. It's crazy. I'm just so blown away by this. Like, this is such an incredible feat. Oh, this one was also really interesting. Doesn't this kind of look like a long spiral? Like, just going around? Ah, this is so cool. Oh, this one was really interesting. I am still trying to figure out what this is. Like, just a necklace of galaxies? Like, what? It's full of Easter eggs. See, this is why my screen time has been, like, solely this website. Okay, that's not true, but, like, I mean, like, you could literally zoom into any random point on this image and you'd find something really weird. Like, what is this? Like, is this, like, a bunch of galaxies? Like, are these just some stars in a cluster? But, like, why is it shaped like that? Feels like I'm looking at a bunch of anomalies I don't understand. I also don't understand what's going on here, but it's, like, really cool that we can actually see these things. They're friends, yeah. Zoom out and it looks like an S? Oh, shoot! I didn't even notice that, yeah. It's an S for Syzygy. It's an S for Syzygy. Yeah, the universe devs had a real great sense of humor. Oh, this was a really cool binary. Like, they just look like twins. Yeah, no, it really is like a fractal, because you can really just zoom out and just, like, see so many things. This is really cool, too. These are two elliptical galaxies, or maybe they're... I think it's a binary star, actually, because they're so round. We must worship the great S in the sky. The new Syzygy constellation has dropped. Yeah, this one was really great because you can see these H2 regions where there's a lot of like active star formation going on. It's this beautiful shade of like baby blue. Yeah, but I also have to say that things looking bigger doesn't necessarily mean that they're actually bigger, because they could also be like closer to us. It's a little confusing because the size of an object that when we look at it is determined by both its actual size, also its distance. The blue is hydrogen, yes. Actually, I mean most of the universe is made up of hydrogen, but this is a very specific type of hydrogen that leads to star formation. There it is, the Boomerang Galaxy. You mean the Boomerang Nebula. The Boomerang Nebula is great. Oh, this is the last one on my list. I mean, I could go on for ages. Like, genuinely, I could literally... This stream could be 4 hours. Like, this stream could be a subathon, and I will literally just go in and look at the galaxies. If I ever do a subathon, I think that would be the best option. Just going through this image. But this is an incredibly interacting galaxy. It just, like, looks like the material is just being, like tossed out into space. Can we see the Boomerang Nebula here? No. I think the Boomerang Nebula is also quite far and very hard to see. I don't think it's in this field of view either. But I can't pull up the Boomerang Nebula. And maybe I should close this tab because I'm literally moving at 3 frames per second. So this is the Boomerang Nebula. And it looks kind of sussy. Or, I guess, Zossy. I absolutely love this nebula. Actually, the Orbeez were the first people who told me about this. And after that, I've been telling my colleagues about it. And I was actually dared to put the Boomerang Nebula in my presentation. And I actually included it as the very last slide in my presentation. Like, this, keep in mind, this was like a very formal presentation. Of course, I didn't actually show it. I put it at the very end after my supplemental slides, so, like, there was no way anyone was going to see it. But maybe for a split second when I started to screen share, is the nebula composed of Among Us? Maybe. I remember the live reaction to it. No, this was literally spectacular. Orbeez, this was all thanks to you. It looks very sussy. Yeah, no, the Among Us, the Zus character. This is great. I'm still moving at like 4 frames per second. I'm not sure why this is the case. Hopefully it'll be a bit better. But yes. Yeah, so these are some of the really exciting finds. And I'll also have this in the slideshow, so if you want to take a closer look, they're also there too. I mean, it is absolutely spectacular. Yeah, Rubin sadly only looks at half of the southern hemisphere. But keep in mind that, like, you might say, oh, it's only half of the sky, but at any given time, surveys have only been able to look at a tiny fraction of the sky. The fact that we are surveying the entire sky is insane to me. Like, 3 to 4, I think it's like 3 to 4 nights, the entire sky is going to be surveyed. Which means we're going to be able to catch, like, a ton of interesting events. When Northern Big Camera, Rubin Observatory number 2, please. This is great. Alright, so, oh yeah, I also wanted to showcase, this. I actually only heard about this recently as well. Oh, I just oh, it's Sky Synth, sorry. Let me turn down the music and I mean, this is really cool. So, for context, the Rubin Observatory public outreach team made this in order to help the people who are visually impaired also experience how epic and majestic this image is. Oh, so if you zoom in, you can also, like, you hover over different things. And, like, there's so many galaxies and they all make really cool notes. I think it's cooler when it's zoomed out so you can hear many notes. Yeah, and it has this weird, like, low-pitched tone when it's near, like, a big object like this. Wait, let me try doing it for this big one here. Like this one's really loud. This kind of sounds like a vacuum cleaner. I love this. Why do the galaxies have to sound so beautiful? I know, right? It's just so cool. I can, like, sleep to this. It's music to my ears. Oh, so pretty. Oh. My cat is loving the sounds. You play the violin, I play the galaxy. If I make music using this, yeah, I won't get copyrighted, I'm sure. Because you are the one controlling the direction. Yeah, I mean, this is... I thought this was a really cool way that they're, you know, helping the people who can't see the image also enjoy the beauty of this. Because, frankly, like, wow. I mean, it's the kind of thing where, like, every person will appreciate how beautiful this is. I mean, it's great. Oh, what? This is so cool. What does a supernova sound like? Well, I mean, there's not... I mean, supernovas are part of galaxies, and so it's kind of hard to see here. I mean, I'm sure, like, if you were to, like, go over in this image, it would just make the same sound as the thing, but... I mean, in real life, there's no sound in space, right? So it doesn't really sound like anything. Ooh, I like the sound these spirals make. Oh, like, look at that structure. I mean... Those blue areas are areas where new stars are being born because blue stars are younger. Oh, wow. Like, they did such a good job with this. You can go here in this, like, interacting galaxy. You can, like, trace along it. Alright, well, I could stay on this website for literally hours. I could literally stay on this website for hours. I'm scrolling around my own and I just happened upon the same spot at the same time you did. Yeah, no, I mean, it's just great. So, I mean, it's great. Are they blue because of redshift? No, these star-forming regions are blue because younger stars are bluer. And they are higher temperature. So the reason why we know that they're actively star forming is that if they weren't actively star forming, then only the old red stars would remain. The fact that we see these young blue stars mean that they must have been born quite recently. Stay on the site, stay on the site. Is this the rest of the stream, Orbeez? Wait, I wonder... Oh, you can have this as, like, background music too. So if you need like lo-fi beats, move aside lo-fi girl, you can just play this. Are we observing the superclusters? Actually, there is a really nice galaxy cluster right here. Oh, actually right here is even better. These yellow ones here are galaxy clusters. I mean, it's so great. Good evening, Kyle. I mean, just... I didn't even know you could do this play feature. This is great. I mean, I would totally make like a lo-fi galaxy version of this, but like, I mean, this isn't even my website, but... Wow, this is great. Well, okay, we should probably move on because I do have a lot of stuff that I want to show you guys other than this really epic website, but I'm just gonna copy and paste this link once again. If you want to play with music, here's the link. I'm gonna replace the pinned message. I mean, it's great. Oh, it also like moves randomly too. Yeah, so if you want to play this in the background, actually, maybe I should just have this playing in the background, Orbeez. That's a, oh. Does it stop once it's, oh, I guess it stops once I'm off it. Wait, I can fix this. There we go. Okay, we're just gonna have this as the background music. I hope it's not too loud. Yeah. We're just gonna have this as the background music as we continue to play this. Actually, maybe I should also screen share these. Mac OS screen capture, music. Oh shoot. Let me not dox myself today. Wait, I hope that was actually fine. I think that was fine. Oh my god. That was really close, Orbeez. Alright, we're okay. We're okay. We're okay. We're good. We're good. Oh my god. Oh, well, I guess you can see my bookmarks, but that's fine. I'm just gonna have this in the corner. Zcursion. Oh, I've really only doxed myself once. I think it'll be fine. Okay, great. Woohoo! And then let me make this a little bit smaller. Actually, maybe I'll move the... Oh, sorry. Technical difficulties. We know that your secret identity is A. Yeah, I guess that was kind of obvious. Alright, great. I think that's a little bit better. And then let me have the slides. And then let me move this a little bit to that way. Yeah, I think that's a great setup. Yeah, this is great. I love this even better. I honestly might just have this as my background music for my future streams as well. Yeah. Alright, so next slide. Oh, yeah. Okay, wait. I actually will have to pause the music for just a second just to showcase this incredible video. This shows how many new asteroids they're detecting. So in just the first look image, the Rubin Observatory found 2,100 asteroids that were never seen before. They found 4,000 asteroids total, but 2,000 of them were new, and 7 of them were near Earth. And I just want to show, like, 2,000 sounds like a lot, but this video really shows how great this is. Asteroid mentioned. Yeah, no, get excited, because this is really cool. So this is asteroids moving around. Like, holy smokes. 7 nights. No, in just 10 hours of observations. Okay, I just need to like, we just need to go back and like pause, because like, what the actual heck? Orbeez, isn't this just crazy? Like, look at all those asteroids. And it's like, this video just has the greatest wow factor. Like, you just see these guys and it's like, where did this come from? And these are all like, there's so many things just out there in space. These are all new. Yeah, these are all the new ones. This doesn't even count the other 2,000 that they found that we already knew about. I don't have any words. I mean, exactly. It's so mesmerizing. This is incredible to me. Oh. Yeah, no, I mean, that is just one example of just how crazy this is. I mean, imagine finding the one that's certainly going to be the end of us. I mean, to be honest, I'm surprised that, like, now we can find it better because we've been missing out on, like, half of the asteroids. It's crazy. Will this sweep that whole side of the asteroid belt? I think that's the plan. I mean, 10 years of observations is a really long time. Actually, that brings me to the perfect point. So, you might be wondering, where are we in the schedule? So, the first light event is over here. That was the images that we first saw. And they're gonna finish things up. They're gonna have construction. They just did data preview. No, I think they're planning to do data preview 1. And then the very first data release will be right here. And then after this, there will be during the start period, there will literally be 10 years of surveying. And this alert stream is where people will get scientists will get notifications about the really cool stuff to be interested in and so forth. And the data releases will also have a lot of data as well. So yeah, this is a lot, but yeah, the rest of this presentation will be focusing more on, you know, the really exciting ways that we're planning to use Rubin Observatory, which is really exciting. Are all the asteroids in the solar system are past it? I think most of the ones that they found were orbiting around the Earth, though I presume they'd also find asteroids in the asteroid belt as well. I mean, it's basically everywhere. Move this a little back. So the specific areas that the Rubin Observatory will look at include dark matter and dark energy, which is this incredibly mysterious form of matter and energy in our universe. Understanding more about the Milky Way, structure and formation. Describing asteroids and comets with the solar system census. And I'll actually describe a way that even you guys can get involved, even if you're not an astrophysics researcher, which is really exciting. And the changing sky, which I will also talk about more in a brief second. We have asteroids around Earth. Well, I guess, yeah, they are like rocky bodies around Earth. Rocky bodies is also misleading. I'd say like rocks. Asteroids, yeah, basically. We actually have 2 primary asteroid regions. Let me see if I can try to find a photo. This is also not my area of expertise. Asteroid around Earth. We actually have 2 specific regions, I think. Yes, this was the image I was thinking about. Oh, this is kind of a crusty photo, but... Oh god, this is like a horrible photo. But... Yeah, I guess they sort of extend around from Earth into the asteroid belt, or they like sort of go around. These are the asteroids that I was thinking. Yeah, we have like crescents. Yeah, let me try to find the Lagrange points one. Yeah, we also have Lagrange points are points where the gravity is more stable. Ooh, we're going over a spiral galaxy in the music. And there also tends to be more asteroids there. I guess they only have a... let me look up Earth, because this is a big thing for Jupiter, but it's also a thing for Earth, too. Please. Okay, I'm struggling to find a good image. But I'll show this one instead, because I think this gets the point in. So, this is for Jupiter, though. But as you can see, there's like asteroids along Jupiter's path that are just in front and just behind of Jupiter. And these are because there are stabilities in the gravitational orbit where these rocks sort of reside. And similarly, there's something for Earth, but on a much smaller scale. Zooniverse has a citizen science project for finding comets and Vera images. Actually, I'm really glad you brought that up, because I was going to mention that at the very end of my presentation. Ways that you guys can get involved with some of the science. All right. Well, let's move on to the next slide. So, LSST, the Rubin Observatory, will discover 1 million supernovae a year, 10 to 100 million active galactic nuclei, or these are like active, like supermassive black holes, 10 million galaxies in just the first look image alone that we looked at, 5 billion galaxies total. Like, what the heck? 5 million asteroids and 100 million variable stars. Absolutely insane. And so, like, you might be wondering, like, how does Rubin the observatory determine what to do? So actually, every 30 seconds, an algorithm decides where to take a photograph. So it actually doesn't like evenly take a photo of the night sky. It's actually not a regular pattern. It actually looks at different regions based off of their different science potential. Like, for instance, if there was a supernovae that just went off, like, obviously you should probably spend more time looking at that, or look at that first, you know? So that's sort of how they go about that. And I just wanted to highlight a few really cool examples, some of which I've actually learned a lot more about the past few days after talking in extreme excitement about this. One example are these events called transient events. This is just a fancy way of saying that an event is time varying. So if you say transient, just think of it as varying with time. And one example is superluminous supernovae, or SLSNE. These are superluminous engine-driven transients. They're believed to be powered by magnetars with extreme magnetic fields. But currently, we are trying to pinpoint where exactly they're located. And they seem to be located in low metallicity environments, so areas with more hydrogen and helium, less heavy metals, and galaxies with high star formation. But the reason why Rubin Observatory is so great for these is because we're surveying the sky literally every 3 to 4 nights. It'll become a lot easier for us to actually find these kinds of events. And the way that they do that is every time a photo is taken of a region that has already been previously photographed, what happens is that first, the Rubin Observatory combines the new image with the previous image taken of that region to look deeper into space. The second thing that they do is that they actually compare the image. And so, for instance, here, you have this image here, and let's say that this was what was taken before, and you notice this little blip. Like, there's no way a human would be able to just spot that just by looking at the photo. But if you were able to subtract the photos, you'd say, oh my god, there was a change here, and this is a supernova event. And if you do this for the entire southern night sky every 3 to 4 nights, you're catching so much more supernovae, which is why we're able to see, or we're predicting to see, around 1 million supernovae per year, which is absolutely unprecedented. I mean, this is literally going to change astrophysics. What's stopping us from putting the Vera Rubin telescope into a rocket and launching it? Well, we don't want to lose it. We don't want to lose it. So many big numbers. I know, right? Like, I think it's also kind of hard to get, like, how insane the scale is. But I think the big takeaway from this is that the Rubin Observatory, because it's scanning the entire night sky, is going to give us a lot more information and give us a lot more monitoring than ever before. I actually wanted to showcase this one. I actually learned about this quite recently. I think I previewed this to the members Discord, because I did like a little update about some of the stuff I learned while doing some research, and this is called Scary Barbie. It is a nickname for a very bright, slowly evolving transient event discovered by ZTF. And that's basically a bunch of fancy ways of saying that it was releasing a heck ton of energy for a really odd period of time. This Scary Barbie event lived for 800 days, so like more than like 2 years. And it released energy more than 100 times a typical supernova. Like, what the heck? So this is definitely not a typical supernova. And currently the theory is that a massive star exploded near a supermassive black hole. And that's what led to the immense amount of energy that Scary Barbie is releasing. So this is important because it suggests that there could be different types of explosions, and they can vary if they are located near these supermassive black holes or galactic nuclei. And these events are like exotic transients, which means that they're very rare. But thanks to the Rubin Observatory, and because we're scanning the sky so often, we'll be able to find more weird events like this. Sus. I know it has a sus name. You know why it's called Scary Barbie? It's because its original name was like, let me copy this. It's like ZTF 20 ABRBEIE. That was the name that was assigned to it. They looked at it and they were like, that kind of looks like the word Barbie, so they named it Scary Barbie. Oh, and I also wanted to highlight this really cool paper. So I think somebody in the chat earlier said, I think Warpy said, like, oh, these are some really big numbers. And yeah, Josem was like, my brain is going to like explode. Yeah, these are a lot of big numbers. So you might be wondering, you know, if you're getting like 1 million notifications every night, how do you know what to look at and what not to look at? And that's actually a really big question that the Rubin Observatory is trying to tackle. So this is an example of how people are using like machine learning to try to detect what events are interesting and what are not. So this is an example of a supernova, SN 2023 ZKD. And I heard this story straight from the source, which was really interesting. Turns out that this group had set up a Slack bot. So if you don't know what Slack is, it's almost like Discord, but for work. And you can set up different bots. And so they set a notification to notify them if they found a weird supernova. And so their Slack bot one day was like, oh, this is a weird supernova. So yeah, I mean, it literally says here, they had this anomaly identification search, and it was integrated into the Young Supernova Experiment via a Slack bot. So they basically just got a message in like Discord that was like, this event looks a little strange. And so the group was like, okay, that's anomalous. Okay, let's do some follow-up explorations. Oh, is the music hard to hear? Oh, sorry. Actually, I might turn off the music if you guys don't mind, because I feel like my computer's heating up. But it is linked in the channel. Sorry. Alright, I'm gonna turn it down. Yep. Thank you so much, 4RC, for pointing it out. So, they looked at this a little bit closer, and it turns out that there was two explosions, so one and then two, that happened as soon as they started looking at it. And then they were like, this is so weird. So they went back and they found that a year ago, there was a precursor event, something that happened before, that led to the double explosion. And this couldn't have been detected without machine learning. And that's Slackbot. So basically, they theorize, this diagram looks really crazy, but I think it's really cool. They're saying that the reason why that this event exploded twice is because that there was material around the star that already existed. So when it blew up, it somehow collided with the existing shell of material. This paper is an absolutely fantastic read. I highly I highly recommend it. Let me see if I can try to 2502. Yes. Is the Vera Rubin going to be a big sky archive? Yes, though you have to imagine that it's a lot of data, so rather than it being an archive, I almost consider it like being like different notifications. I mean, it depends on what kind of science you're doing. It could be, in some ways, a way to track different things happening in the night sky. But in other ways, it also means that because you're getting so many images, you're able to look further into space than ever before. Yeah, so I highly recommend this read. It's so much fun. And they're saying that, you know, they used a random forest classifier. Basically, they trained their model on a large data set of known supernovae. They looked at the different light patterns of different supernovae, and from that, they were able to use this Slack bot to identify and notify them when a weird event happened. And in this case, it turns out that it was a really good idea for them to look at this weird event because it ended up being even stranger than they expected. Yes, so supernovae happen when stars reach they basically don't have enough energy. And so they start fusing heavier and heavier elements, and at some point they are unable to support their mass. They collapse inwards on themselves, and then they explode out in a giant explosion. These explosions are some of the most powerful energy releases in the universe. I'm sure there'll be applications for the data set. Yeah, no, I mean, the machine learning space, especially in astrophysics, has been incredibly insane. But this was a really great example I wanted to highlight, which shows that even though we'll have a ton of data, there are a lot of new methods that are coming into place that will help us understand and identify stranger events. All right, I think I'm good on time. So the next thing that I wanted to talk about, which is also exciting, is the fact that we literally don't know what 95% of the universe is. I wasn't sure what emoji to put here, so I put that one. We don't know what dark matter is. We don't know what dark energy is. Everything that you can see, touch, feel around you and in the universe. Okay, well, see, touch, yeah, feel around you in the universe is atoms. So we don't know where 95% of the universe comes from. And the person who actually helped discover this was Vera Rubin herself. So Vera Rubin, she actually died in 2016. She was an American astronomer who basically found evidence of dark matter in galaxies. The way that she did that was that she measured the rotation rate of galaxies, and she found that there was a big difference between the expected rotation rate of galaxies and what actually happened. So what you'd expect is this dashed line down here. You'd expect that as the distance to the galaxy goes away, like the rotation slows down because there's less material. But what's interesting is that it seems to flatten out instead. So Vera Rubin looked at the rotation rates of the Andromeda galaxy and some others and found evidence of this discrepancy basically everywhere, which means that the reason why there's a big difference here is because there's a lot of stuff on the outskirts of a galaxy that we simply can't see. And that was later to be dark matter. So yeah, so Vera Rubin is basically the origin story behind dark matter. And it's really great because the Vera Rubin Observatory will be used to help map dark matter. So you might be wondering, well, we can't see dark matter. Like, how do we map it? Like, Z, you are entirely wrong. Well, the way that you map dark matter, one of the ways, is to use gravitational lensing. So lensing is basically like a core idea of general relativity. It basically states that if you have mass, it bends space. So when you have light, and the light is bent around an object, that implies that there's mass in the center. So this diagram here is a really good job. There's mass here in the center, and then the light of this galaxy behind it is being bent so that you can see it. And that appears something like this, where you see like a ring or some sort of distortion of a galaxy. If you have ever seen Interstellar, it's basically like, it sort of looks like that. So this also applies to mass that is not visible. So dark matter could be in here, and the distortion of the light will still happen. So that's how we map dark matter. Now, this is obviously in an extreme case. You need a big galaxy or a galaxy cluster to get a beautiful ring like this. So what scientists actually do is a little bit on a smaller scale. Let me try to move my slide a little bit. And they do something known as weak lensing. Basically what they do is that there are a bunch of galaxies here, and there are incredibly tiny distortions that aren't even visible, like when we look out in the night sky. But these represent smaller regions of dark matter or smaller distributions of mass. So the way that we map mass in the universe is by basically using general relativity, by seeing how the light bends around mass in the universe. I mean, the dark matter is definitely not dark space rocks and dust. I mean, it's not visible at all. The current theories say that it's particles, but the real question is really how it behaves. So for weak lensing, you need statistical analysis across thousands to millions of galaxies, which is where large surveys like Rubin Observatory can help. So the biggest survey that had previously done this is a dark energy survey, which did about like 1/8 of the sky, and it sort of looked like this. This is a dark matter map from the dark energy survey's observations, and you can see where there's like overdensities and underdensities of material. The Rubin Observatory is going to be half of the sky, and it's going to be looking deeper, bigger, and more precise. And it's going to be looking for like 10 years. Over 20 billion galaxies. So it uses the distortion and patterns in the matter to make the map of matter in the universe. And this is a really important question because the more matter describes, how quickly the universe evolves, it helps us answer questions of how fast is the universe expanding, how fast does structure grow, how did structure grow in the past, and so forth. So this is a really exciting era, and I mean, this comparison is great. I mean, instead of getting just this, you're getting like literally the entire bottom half at even greater precision than before. Yes, whatever dark matter is, it doesn't interact with the electromagnetic force, so no light is emitted. Yes, that's correct. That's why people say dark matter is invisible, because you literally can't see it. Wasn't there a big issue with the missing mass in the universe where we couldn't account for all the... I think you're talking about... Wait. Okay, because there's like two things that come to mind. I don't think you're talking about the galaxy one. I think you're talking about the results from the, Yeah, wait, let me quickly double check this. Yeah, I think I read about this briefly. Yeah. Yeah, the DESI stuff, yeah. Yeah, that is basically for mapping the cosmic microwave background. They found like undetected clouds of hydrogen that were undetected because they were cold and ionized. And like that ionized hydrogen gas scattered the radiation. Yeah, the new measurements have seemed to found this missing matter in the form of very diffuse and invisible ionized hydrogen gas, yeah. Yeah, I think that's a bit different from this, though. Yeah, so in Model Z, yes. Yeah, mapping dark matter sounds so insane, like something we should be doing in 100 years, not now. Let me just do that. Okay, moving on. So one really exciting thing about, yeah, sorry about the chat. Okay, anyways, no, it's just, there's some channels that just come in and like to bug people, I guess. Yeah, don't worry. Okay, so one of the favorite quotes that I've heard about this, about the Rubin Observatory, is that the Rubin Observatory will give all astronomers a big data problem. Because the amount of data gathered in the Rubin Observatory in its first year alone will be greater than that collected by all other optical observatories combined. Like, that's actually insane. Like, every single observatory that we've worked on is just so surpassed by the Rubin Observatory. This will literally be hundreds of petabytes. And doesn't even include like the follow-up observations that will be done after the Rubin Observatory and the simulations and stuff like that. So every 37 seconds, an image will be taken, which means, oh, I even underestimated. I thought it was 1 million alerts a night, 10 million alerts a night. Like, just think about your phone just like going off 10 million times a night. So obviously, this is a big issue. The Rubin community basically has designed a solution to this, which is that they know that different communities are interested in different things. Like, there's asteroid people, there's like planet people, there's galaxy people, there's dark matter people. Like, there's a quick turnaround. People want their data. People want it to work like clockwork. And so what the Rubin Observatory people have done is that they've built a science platform that will be sort of the entry point to look at all the data. This science platform has all of the data on it, and it basically means that if scientists want to access Rubin data, they'll just have to go through the Rubin science platform. And at the end of the 10 years, we'll be sitting on like more data than, you know, we've ever experienced to date. I mean, they spend 5 months every year just to do the data releases, which are also incredible. I want to be a dark matter people. Yes. Will all the data fit on Earth? I mean, if I recall, like, I don't think it's actually that big of a deal. I think it's about like 1,000 computer cores. I mean, I'm sure they definitely have a lot of supercomputing clusters and stuff. That being said, like, it still is a heck ton of data, which is why they've sort of built their own internal platform so that, you know, instead of having people exchange data and send data and like, you know, they have it all in one place. So, yeah, this last slide here I've actually taken from a presentation from the Rubin Science Assembly. If you are a scientist, these links are more relevant to you. But it sort of goes into detail about, you know, like if you're a scientist, sort of how to get involved. They did like data previews and stuff like that, so you can look at the data. They have these community forums, and most importantly, the Rubin Science platform, which is where they're going to actually host the data. And if I recall correctly, they're also doing several workshops, but I'm not sure if these are available to the public. Basically, the Rubin Science platform is located next to the data, so it has like storage space, compute resources, and like remote access options. It's really great. Yeah, so it looks something like that. Yeah. Alright, so that was the bulk of the presentation, but you might be like, but Z, I want to learn more, please. How can I get involved? Like, I'm not a PhD, please. So, I think somebody mentioned this earlier in chat, and I wanted to point people to this too. The Rubin Observatory is being very transparent with crowd science projects. They actually have a partnership with Zooniverse, which is an absolutely spectacular website. So, that was exactly what I was thinking. I know, right? I can read your minds, Orbeez. So one example is this crowd science platform where you can help find comets in Rubin data. And this is open to the public, and you can help out. And they have a lot of data that they're sitting on. So this is one really great way that you can help out in terms of the citizen science end. And if I recall correctly, they're also going to have a few more, yeah, they actually have a partnership with Zooniverse, and they are going to do some more partnerships, some more Zooniverse things. So yeah, so you can help find comets in Rubin data, and this is open to the public. And in addition, you can also help find other really exciting things in Rubin data without being a PhD or professor. How can you have dark matter stars? Well, there are no dark matter stars, because stars are made of physical matter. Zotato, yeah, Zotato made an appearance. I was trying to look for something to like turn into a comet, and I guess it was roughly the same color scheme. Be right back. Yeah, no. Well, you should be finding comets, Orbeez. What are you doing? You need to log in right now and find all the comets. I expect this to be completed by tonight. But no, it's great. I mean, I think it's one thing that this program is an absolutely incredible feat of humanity, but also that they're having these really exciting avenues, and I think this really gets people talking. If you think about it, being involved in these citizen science projects are also a way that you are applying the scientific method, right? Like, you're forming a hypothesis, you're seeing if something's a comet or not, you're helping contribute to real science, and a lot of these results tend to be published. Is there sort of a like folding at home style crowdsourced compute project? So if you go to that link that I sent up here, citizenscience.lsst.io, they have some more information about where they're going to be hopefully releasing some data sets to the public. If I recall correctly, they are planning to have like a few broad data sets. Some of the, like most of the data. Okay. Let me think of a good structured answer. So the Rubin Observatory is great in that they don't have a proprietary period, which means that as soon as the data is collected, it is accessible to scientific institutions and the scientists at those institutions at the US and some selected international partners. That being said, I don't know how public that data will be, and I unfortunately don't think that it will be too public, but if you go to that website and if you follow around some of the links, there will be ways that you could get involved and help contribute to some larger data sets. And I'm sure that they'll also partner with some other like citizen science websites so that you can analyze the data for your own. Publishing a paper to that effect. Ooh, I haven't heard of dark matter stars actually, but I have, there's been a lot of chatter about, I mean, this is pretty well known in the community right now, that dwarf galaxies, which are small galaxies, have very little stars and are actually mostly made up of dark matter. And we have also found galaxies that are just made of dark matter, or at least like majority dark matter. And we have found galaxies with little to no dark matter. So there's been some interesting finds here and there. They think Jade's G... Let me take a look at this. I've not heard of this. Oh, this is a galaxy, though. Yeah, this is a very distant galaxy. Oh, I think I've actually heard of this. Yeah, because at some point it was like the furthest galaxy, yeah. But this is a galaxy, which is different from a star. But I'd be happy to read the paper. I've read a bit about this, actually. So yeah, so check out this website. They have a really exciting partnership with Zooniverse, and you can go identify comets. Another way that you can get involved is by just sharing this website. I feel like, I mean, obviously being in the astrophysics research space means that, like, I get to talk a lot about this, and you guys get to also hear about it from me, as my Orbeez, but, you know, I feel like there's a lot of people out there who don't really understand the extent of how incredible this telescope is. I think even sharing this website is a really great way that you can have people learn about the really cool stuff that's out there in space. Or you can also show them the one with the sound, which is called the Sky Synth version. Alright, so that's it for my presentation. I know I'm running I typically only stream for about like 90 minutes at a time, so I know I'm running a little bit over time, but I just love to yap about this. I mean, it's super, super, super cool, all this exciting stuff that's going on. So yeah. I actually have a few more slides left. Dark matter sounds like matter that exists in another spatial dimension that interacts with our three-dimensional world. Actually, Josem, one of the current theories in particle physics, I'm not an expert on this, but I looked into this in the past, is this theory called, like, the hidden valley model, which is this idea that dark matter resides in this hidden dimension known as the hidden valley. And this dimension is impossible to access. Well, it's almost impossible. Currently, they believe that you can access it using higher energy schemes, using powerful particle accelerators like the Large Hadron Collider. And the way that they access dark matter is that using the power of the Large Hadron Collider, you can basically have a mediator particle go between our current world of the standard model particles and the hidden valley, and sort of like reach in, grab a bunch of dark matter particles, and have them decay in the standard model. And what that would sort of look like is just a bunch of standard model particles appearing out of nowhere. So this idea of the hidden valley is not as hidden dimension is not as far off as you might think. Never stop yapping. Wait, the place where ranch comes from. Oh my god. If I ever talk about the hidden valley again, I'm gonna say that as a joke. Oh my god. I know, it's really weird, right? It's really weird. Here's a DOI on my senior research. Okay, let me see this. Let me see if I can find a PDF version. Please. Please don't dox me. I think, I don't know if I can screen share this because my institution might pop up. Hidden Valley Ranch particles, the true identity of dark matter. Oh, actually, I think I'm fine. Oh, this is actually quite... Oh, it's actually a short paper. Dark Stars Code. I've never heard about this before, actually. To be fair, I've not studied WIMPs, which are the weakly interacting particles. Sorry, Orbeez, I'm just reading through this real quick. I have some doubts, I'd say, just because stars themselves don't have dark matter, but they're definitely in galaxies. I'm wondering if that what you made... I guess what they're arguing here is that stars capture a large amount of dark matter. Yeah, I'm not sure. I think, that being said, I don't really know much about the dark matter star simulations, but I think as of now, the current consensus is that dark matter exists in galaxies, but you can't really make a star out of dark matter. Well, anywho, that was a really cool read. Thanks for sending. I'll take a closer look after stream. Okay, so, I just wanted to spend some time with some really exciting final announcements. Orbeez, you all are invited to my first Earth birthday, which will be on July 7th. Isn't that so exciting? That's actually in 4 days. I know, I haven't been, you know, keeping it too loud. It's gonna be a great time. I have an idea on what to do. I'm not sure if this will be controversial, though. The hint is this forklift here. I think that's the current plan. If you know, you know. If you don't know, you will know in 4 days. Happy birthday, thank you. Yeah, so I'm really excited for that. It's my very first birthday. And I think my streaming anniversary is also coming up at the end of this month. Are we getting forklift certified? Maybe? My birthday is July 8th. Wait, no way. Happy early birthday. Thank you. Well, I hope I'll see you guys on stream then too. Another really exciting announcement. On Wednesday, next Wednesday at 7 p.m, Nep and I are doing our second collab where we're still planning to do things, but we might be debunking, I think we're going to be debunking misinformation in plant science and space. Really, really cool. This you know how this collab came to be? I just want to zoom in on this screenshot here. So Neb DMs me with this video that I've been seeing all across my YouTube recommended and have also been sent several times, which is this video was Oumuamua, an alien ship, everything we know so far. And just, I haven't watched it, but I just know from the thumbnail that I will actually like implode if I do. So I responded, bro, what? I will actually crash out if I watch this. And then following this video recommendation, Neb was saying, you know what would be really great? If we did a collab like on conspiracy or like misinformation stuff. And we were just like, that would be great. So we are planning to do a collab. And for those of you guys who do not know who Nep is, I'm actually part of a VTuber group called V-Theorem, which focuses on scientific communication. And Nep does horticulture content, and she streams on Twitch, which is great. And finally, last but not least, I also wanted to send this, oh, let me try. Oh, I'm not actually sure what the date of this will be. Let me just double check that link is working. Yay! Okay, cool. So I'm planning to do another late night drive number 2. I was planning to do that like this week, but I'm actually traveling again. So I will be out of town after Nep's stream for a few days, so it won't be too bad. But when I come back, I definitely want to do a late night drive number 2, or it might be an early morning drive. It actually seems like the majority is saying early morning drive. So, yep. So if you want to submit questions, go to that link up there and submit any question that you'd like. It can be anything from physics. Last time we had some really great nerd conversations about like dark matter and galaxies, or it could even be about like me and like, or as much about me that I can disclose without doxing myself. Yeah. Another collab? Heck yeah, no, it's really exciting. I've actually collabed with everyone in V-Theorem except Syzygy, which really sucks because Syzygy and I have been trying to plan a collab for the longest time, but our time zones are the furthest apart, which is really unfortunate. We're gonna try to make something happen, so fingers are crossed. We already have so many ideas, though. We have so many ideas on what we want to do. The issue is just finding a time that's not like 6 a.m. for me or like 8 p or like 10 p.m. for her, you know? V-Theorem has no pure mathematicians, yeah, or chemists, or like geologists, or astrologists even. Silver says, I'm so glad I caught this stream. I always miss when you stream. Yeah, no, I was gonna say, if you're watching this on VOD, or if you caught this stream and this was like the first time you have, go to that forum and vote for an early morning hour, because I know there's a lot of European Orbies who kind of struggle with this time, and I know I've been streaming at this time zone. Yeah, so please let me know. Anywho, that's all the announcements from me. And yeah. So, oh my god, we are almost at 2 hours. Astrology stream when? I've done an astrology stream. I debuted as the astrologer on April 1st. I actually thought that stream was really informative. I actually thought, there was a lot of, education in that stream. I'm gonna just have this as the background for a bit. Yeah. Here, let me like reduce the sound. I mean, this is great. So, I think that's it for me. Thank you all so much for joining. The A stream was a good stream. I almost died from laughter. Honestly, same here. That was like the craziest stream of all time. Actually, let me see who's streaming right now. Oh wait, Carbon's streaming! Wait, Orbeez, do you guys want to try an unofficial raid? I think that would be a lot of fun. I think, oh look, Carbon's actually talking about the SpaceX rocket, so I think that'll be a perfect segue. Cross-platform raid. We're gonna make this happen, Orbeez. Thank you all, oh, what? Okay, thank you all so much for joining. I will see you guys in the next one. So until then, everybody go hop on Carbon Stream. I'm gonna type Z-Raid right now. So you all better go join. All right, thank you all so much. I hope you learned a lot. If you have any questions, please don't hesitate to put them into the Discord. I will get back to you as soon as I can. And for the new members, thank you all so much for supporting my channel. It really means a lot. I'm really grateful for all of your guys' help and incredible enthusiasm. I just love talking about galaxies, and you guys make it even more fun. So, until next time, I will see you guys later. Bye-bye. Bye-bye. Bye-bye.